Hello everyone, welcome to the next foldable in your chapter 8. We are now at 8.3, 0 and negative exponents. You should all have your foldable. And we're going to be filling out the table of contents like this. And then we'll be doing the goal. So there's table of contents, pause as needed, and we're going over to the goal. Okay, your goal right here is 8.30 negative exponents. Goal, I can correctly apply the 0 and negative exponent properties, so simplified expressions have only positive exponents. We know that there are three ways that we know that we have a simplified expression. That is, each base is only represented once. All of the numerical values are in their most simplified form. And then the other one that we have been disregarding so far, and that is there can only be positive exponents. So if we have if we have negative exponents, we have to learn how to deal with them and turn them into positive exponents. So that's what we're going to do today. So here's your goal, pause it if you need it, and then we're going to move on to the actual foldable. Okay. So first off, we're going to start with 0 exponents. Okay, we already have sort of learned it, but now we're going to put it into your IMJ. So here you go. 0 exponents for when b to the 0 equals 1, when b does not equal 0. So that's just basically saying you can't have 0 to the 0, but every other number to the 0 is 1, even variables. Well, how do we know this? Well, we know that 20 to the 3 over 20 to the 3 is 8,000 over 8,000, and we know that any number divided by itself is 1. So that means that if we were to then use our division property, where we go 3 minus 3, so 20 to the 3 minus 3 is 20 to the 0, and then 20 to the 0 is 1. We know that anything to the 0 is 1. Okay? That's pretty straightforward. We've talked about it a lot already, but now we're finally writing it down. So the trick is whenever you have a power that is 0, basically whatever the 0 is attached to vanishes. That's how you're going to end up dealing with things that are to the 0 power. Just get rid of them. They're no longer there. They go bye-bye, okay? So from now on, if you ever have anything to the 0 power, make it go away, because that's all that we want done with it. Okay, let's talk about negative exponents. We learned yesterday that the reciprocal, that you use the reciprocal to find the negative exponents. How does that apply in terms of the property? Well, here you go. Here's the property. B to the negative n equals 1 over b to the positive n. That means we found the reciprocal of the exponent, and that turned a negative exponent into a positive exponent. The other way to look at it is if we have 1 over b to the negative n, once again, we find the reciprocal, which, as we remembered from yesterday, is flipping the fraction. You find the reciprocal, and the exponent becomes positive. How do you get rid of negative exponents? By finding the reciprocal and turning the exponent positive. You'll notice that the base doesn't change. The base doesn't go from negative to positive or positive to negative. The base remains the same, okay? So what does that look like? So here's a couple of proofs here. We have, let's just zoom in here. We have 4 to the negative 3 becomes 1 over 4 to the positive 3. I drew a little positive in there. It's kind of optional. Well, you don't have to do that ever. I just wanted to show you the difference. So 4 to the negative 3 becomes 1 over 4 to the positive 3. Over here, we have w squared over 5 to the negative 2. I drew an invisible 1, so we remember that. It technically right now is 1 over 5 to the negative 2. And in order to find the reciprocal, we flip that part of the fraction. So 1 over 5 to the negative 2 becomes 5 to the positive 2 over 1. Now, if you're actually writing your eventual answer on the right-hand side, you wouldn't have to have this negative 1, this fraction bar with a 1 on it. You wouldn't have to do that at all. But that's just me showing you that we flip the fraction, okay? How does that end up looking? You don't always have to think about it as flipping the fraction, but you do have to think about it in a very specific way, and I'll show you what that is right here. So here I have negative 3 to the 1, x to the negative 4, y to the negative 3. So you'll notice that the negative 3 has a positive exponent, has an exponent of 1. So whenever you see a positive exponent, you leave it alone. You're done with that part of it. You just leave it alone. But whenever you see a negative exponent, you have to change the side of the fraction that it's on. So we have a negative exponent here. So because it's negative, we have to change the side of the fraction. It's on the top, so it ends up going on the bottom. Same thing right here with the y to the negative 3. It's a negative exponent, so we have to change the side of the fraction it's on, and it goes over here and becomes y to the positive 3. So the basic idea, the basic rule of how this works is, wherever you see a negative exponent, it has to change. It has to change the side of the fraction it's on. So is it going to stay put? It stays put if it's positive, and it moves if it's negative. Okay, let's do some examples on the inside. Okay. Here's some examples. Pause as needed. So we have 4 to the negative 2 over 1. This one's pretty simple. All we're doing is flipping that fraction, right? So so that becomes 1 over 4 to the 2. Because all you have to do is flip that fraction and the exponent becomes positive. Okay, here we look at this and we say, well, this 4 is a positive exponent, so it stays. This x to the negative 3 is a negative exponent, so it moves. It moves from the bottom to the top. So our answer is simply 4x to the third. That's all. All you have to do is move it, and you're done. Okay, over here, our 5 and our 3 are both positive exponents, so they stay. The 5 and the 3 are positive exponents, so they say they do not move. But the a and the b have have negative exponents, so they have to move. They have to change the side of the fraction that they're on. Okay? So the b is going to end up moving to the top, and the a is going to end up moving to the bottom. And so when you write your answer, you have 5b to the 4 over 3a to the 2. All we did was we changed the location of where the negative exponents were. They changed from the top to the bottom or the bottom to the top, and their exponents became positive. Okay, over here, we know that 8 to the 0 is 1, and so there's that. And then this guy we know is going to move to the bottom. Well, when it moves to the bottom, what's left on top? It seems like nothing, but when there can never be a nothing at the top, on the top of the fraction there. So it's going to be a 1. We know that there's an invisible 1 here because everything, you can multiply everything by 1 and it stays the same. So we basically, when we rewrite our fraction, if you ever end up where there's no other terms left on the top, then you just leave a 1 there behind. So we're going to end up with 1 over negative 5 to the positive 4. Okay? The 1 was left behind. Okay, let's do some more. Okay, so we know that this 6, even though the 6 is negative, the exponent on the 6 is a 1, and therefore it stays because the exponent is positive. The 3 also has a positive exponent, so it stays. This k has a negative exponent, so it moves. We will move that negative exponent. So when I write it, negative 6 stays on top, 3 stays on the bottom, but the k will go to the top with a positive exponent. Over here, what happens if x is 4? So let's just figure this out. So we end up with 4 to the negative 2, which means we end up with 1 over 4 to the positive 2, which means we have 1 over 16. This time they wanted us to actually solve it because they gave us an answer for the variable. Okay? Over here, hey, does it matter what t is if it's to the 0 power? Do we have to even plug anything in? No. Everything to the 0 power is 1. So we'll keep it at 1. That's all we have to do. That's pretty simple. Okay, last problem. Now we have to substitute these numbers in for our variables. So let's just rewrite the equation with the substitutions. So we have negative 8 times 4, because that's what m is, to the negative 1, times n is 2 to the negative 2. Okay? Well, we know that all of this right now is on top of the fraction. We know that there is a fraction bar here and a 1 on the bottom, so that's always there. So we're going to take the 4 and move it down. We're going to take the 2 and move it down, and we're going to leave the -8 up top. So we end up with -8 over 4 to the 1 and 2 to the 2. Okay? 4 to the 1 is 4, 2 to the 2 is 4. So we have 4 times 4, which is 8. So we end up with -8 over 8, which we know is -1. Okay, that's it. Thank you very much.